Welcome back. Welcome back to part 2 of this 3-video series where we take a look at some free response calculus questions courtesy of the University of Houston. So get yourself ready, grab a notebook, a pencil, or a pen. This is math from the void. Math coming at you out of nowhere. And in this one, we have an integral problem. We're going to be using the calculator for this as well, and I'm going to show you how to breeze through these approximation methods of integration. That means the LRAM method. That means the RRAM method. That means the MRAM method, the midpoint method. Now in this case, we're just taking a look at the trapezoid rule. So we're going to be applying the formula for the trapezoid, but this could be applied to any approximation method that they give you. And you'll be able to use Desmos's very convenient tabular capabilities. I'll show you how to do that. Now, a disclaimer again, because these questions are generated from University of Houston, which was very nice of them. However, these questions, or these parts in this question, it's not very hard, especially with Desmos. So I think you should expect questions that are quite a bit harder than this one, especially. But the concept is the same. So this is actually a really good learning opportunity. I think you should give yourself about 12 minutes, honestly. I don't think you need the full 15. If you do, that's okay. Don't feel bad. But you should start speeding it up with problems, especially that are this easy, because you're going to want to expect that the problems are going to be harder, much harder than this on the exam. So if it takes you 15 minutes to do the easy one, you might not finish the hard one. Okay, when you're ready, you can come back, resume the video, see how we do. All right, let's get started. Now, we're letting f of x be equal to the integral from 0 to x of cos squared t dt. I want to make this clear that cos squared does not have an antiderivative. You could manipulate the equation and then take an antiderivative, sure, but it does not have an antiderivative. It's not a function that when you take a derivative, it just looks immediately like cosine squared. So this is definitely a calculator problem. And it's defined on the interval from 0 to 3 pi over 2. Now, they want us to approximate f of pi using the trapezoid rule. So we want to approximate the integral from 0 to pi of cosine squared t dt. And if we're using n equals 4, that means that we're going to be creating our trapezoids from 0 to pi going by fourths. So here we have 3 pi over 4, and here we have pi. Now, recall that the trapezoid formula comes from taking the height at these endpoints and then connecting them, sort of like this. Right? Where the height of these trapezoids is actually the delta x between the points, which in this case is pi over 4. And the formula for the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So this is going to be 1/2 times f of 0 plus f of pi over 4. But then it's going to be times the height pi over 4. Now all of the trapezoids are going to have pi over 4 in it. I don't know necessarily that it goes up like this, I'm just drawing it, but when we make our trapezoids and we add them all up, you'll remember that we're going to end up with h over 2 factored out of all of them, base 1, which is the height at the first point, plus 2 base 2, which is the height at the second point, and that's because it's using this side for multiple trapezoids, for more than one trapezoid. Then we have 2 base 3, and so on. Oops. And we have 2 copies for each of them except for when we get to the very end. So we're only going to have 1 base 5, just like we only had 1 base 1. Okay, now that being said, this is very easy to do on Desmos. Let's see how it's done. If I want to evaluate cosine squared, I can do this. I can edit the list, turn it into a table, and now I can plug in values 0, pi over 4, pi over 2, 3 pi on 4, and finally pi. Now these are some pretty nice values, and you'll see that they were highlighted here. So how do I make the rectangles? I mean the trapezoids, sorry. This is very simple. If I want to multiply by h over 2, this is going to turn into pi over 4 over 2, or pi over 8. So I didn't type in y equals, I just typed in pi over 8, and that's going to be giving me a value here. Now I'm going to multiply this by, oops, one big thing that I should change here. I should call this f of x. Let's make a new table. I'll be fast. Okay, so I want to take pi over 8, and I want to multiply it by base 1, plus 2 base 2, plus 2 base 3, plus 2 base 4, plus base 5. So I can simply plug in f of 0 plus f pi over 4. Oh, that's not where that belongs. Plus f of, plus 2, times f of pi over 4, plus 2 times f of pi over 2, plus 2 times f of 3 pi over 4, plus f of pi. And put that all together, and we get 1.5707, which could be rounded up to 1.57. Okay, so we can say that this is approximately 1.571. That's how we use Desmos very quickly for this. Now, if we needed to do LRAM, we would do a very similar setup. We just wouldn't have the trapezoid formula plugged in here. We would be using these values here very carefully, but you would just have to plug them in terms of f, right? Like if we were doing, let's say, rectangles LRAM, this would just be plus f of pi over 4, plus f of pi over 2, plus f of 3 pi over 4, and then I would stop there. I wouldn't use the last endpoint. Yeah, this would be it. RRAM, you would do the same, but be plugging in pi. So it's very easy to evaluate, as long as you know how it's supposed to be written out. Okay. Now let's continue, because part B is so easy. I was willing to take my time in part A. We can talk about part B. It just says find f prime. So we just have to use the Fundamental Theorem of Calculus. I think it's called part 2. I don't really keep track of which one's called part 1 and which one's called part 2. It doesn't matter to me. But if we have to take a derivative, sometimes there's some fancy stuff going on with the limits. Like if this is not just x, if it's like 3x squared or something, and if there's an x thing here and an x thing here, there's a little more to the process. But otherwise, it's really just going to turn into cosine squared x. Not even dx anymore. The idea being that we're taking the derivative of the antiderivative. So if we didn't know what the antiderivative was, let's just call it u. We would say u of x minus u of 0, and we would be taking a derivative of that. And since this is an antiderivative, it would just turn back into cosine squared. Yeah. Okay, so that pretty much does it. It's just cosine squared. Now let's take a look at part C, which is also very, very easy, I believe. Find the average value of f prime, that's important, on the interval from 0 to pi. So the average value, you'll remember this as like, sometimes we say 1 over b minus a times integral from a to b of some function, whatever we're trying to find the average value of. Or you might see it as a fraction like all over the b minus a. Doesn't really matter. But what we're going to do in this case is we're going to be doing that with f prime. Well, I guess it's the way that they write it. It's capital F prime. And this is over from 0 to pi, so this is going to go over pi. Let's change those limits. Now, what does this come out to be? Well, it's the integral from 0 to pi of cosine squared. Which we didn't exactly calculate, we approximated it, but we could easily calculate that with this. Let's do it here. We can eliminate the table too. We don't need any of this stuff actually. 0 to pi, cosine squared of x, what's missing? Dx. Since there's only one term, I don't need the parentheses here, but just remember that you could potentially need parentheses if you have like several terms and stuff like that. Okay, and big surprise, 1.5707. So our approximation was actually rather good. Now we have to divide all of this by pi. 0.5. Wow. So the average value is 0.5. And I think this makes sense if we take into consideration what the graph looks like. Did you guys get a catch of what the graph looks like? It looks like a cosine graph, but it's only positive. Like it doesn't go all the way down to -1 and back up. So it makes sense that the average is like, oops. I try to use the pen feature like I was on the Miro board. It makes sense that there would be like an average right through there. Right? Because it spends just as much time above it as it does below it. That's sort of the idea there. Although if you had different limits, if you didn't go from 0 to pi, if you went maybe from, negative pi over 4 to 7 pi over 6 or something, you might not get that clean average value. Okay, but that is it for this problem. Like I said, a rather easy problem. I don't think you should feel incredibly pressured for time if you get a problem like this, especially with Desmos capabilities. I think it's a lot more likely that they tell you to find some missing values. Maybe they'll give you the value of an integral, or they'll tell you the average value, and they'll ask you where could you cut the region in half so that the area is exactly half or something like that. Anyways, this is all speculation. I hope you learned something. That's enough blab out of me, but I just wanted to teach you guys a bit on how to use the Desmos calculator. I'll see you next time in the void.